Hi, this is Srikanth Yadav, working as Assistant Professor in the Department of IT, VFSTR Dmt U3 University. So in this data mining lecture series, till now we completed the fundamentals of data mining, various approaches used in data mining, classification of data mining and functionalities of data mining. And when we move to unit number 2, we have seen various data pre-processing approaches which are going to be used on the data. Now in this unit number 3, we are going to discuss about what is the use and working of association analysis and how can we apply association analysis in real-time applications, and we will see some suitable examples, and we will continue and we will study the various association algorithms which are going to be used in data mining applications. Let's move to the content. So in this unit number 3, we are focusing mainly on association rules and association analysis. Let's have a look on this learning objectives and learning outcomes. So here our intention of this unit is, the main objective of this unit is, we are going to study about association analysis and association analysis techniques, and also we'll see the various working of association algorithms. And upon completion of this unit, we will have a comprehension knowledge on association analysis, how this association analysis and association mining is going to be applied in real-time applications, and we'll see the working of each and every algorithm as per the syllabus. Now the proposed syllabus for this unit will cover the basic algorithms which are going to be used in association mining and association analysis, and some of parallel and distributed algorithms. That means when we are having large amount of data, and various approaches have been proposed to deal with association related activities, and we will see some of the concepts which are related to incremental rules, and finally we will see the advanced association rule technique along with the measuring of quality of each and every association rule. Now in this the main goal of this unit or this lecture series is, here we are going to provide an overview of basic association rule mining techniques. That means what are the fundamentals, basic terminology which are going to be used in this association mining analysis. So here we will focus on the basic terminology which is going to be used in association mining. This is our primary prerequisite which is going to be used, and what are the measuring techniques in association mining is going to be studied in depth analysis. And we will see when we are having large number of data item sets or item sets, how to deal with these large number of data item sets in order to perform effective data analysis. And we will see commonly used algorithms in association mining. They are a priori algorithm, sampling algorithm, partitioning algorithm and parallel algorithm. These are the commonly used and mostly used algorithms in association rule mining. In addition to that, we will compare various techniques and we will see the advanced association rule mining algorithms. Now to understand betterly what this association is going to be done in association mining analysis, let's have a look on this market basket analysis. That means, let us assume we are having a supermarket. In that supermarket, the purchase history and the shopping history of the customers is going to be analyzed so that we can identify the hidden patterns of the customer, or you can say purchase behavior of the customer can be analyzed. Based on that, we can increase the business. So in this aspect, market basket analysis, which is one of the commonly used area or domain by using association mining approaches. Now here we are having a statement. Have a look on this. Here we are comparing two products, which is On the left hand side we are having a butter. On the right hand side we are comparing peanut butter. On the left hand side we are having an item called bread and we are comparing with peanut butter. That means how many number of customers have purchased bread along with peanut butter. It is not compulsion that every customer has to buy peanut butter along with the bread. Here we are observing all the transactions, that how many number of customers have purchased bread along with the peanut butter. That means here we want to see the relation between these two products. How many number of times it is repeated, and again how many number of times this can be possible to happen is going to be considered here. Now what is the use of this market basket analysis? Mostly we can use for the following area. We can use for advertisement, to increase advertisement, or using advertisement we can extract the customers, and sales to increase the sales information. Here the major objective of this association analysis is we want to increase the sales and we want to reduce the cost. Now we'll see the definition of association rule mining. So here in this definition, the definition is composed with some terminology or technical keywords which are going to be used in throughout this mining analysis. Let us assume we are having a set of items, that is capital I. We are having a set of items capital I. The capital I is composed of m number of items like I1, I2 and IM. Let us assume these are various products which are available in a supermarket, and number of transactions which are performed during the shopping by various customers, or you can say all of the customers, have been recorded in a data set called D. So D is a data set where we are having all transactions related history, where I is having list of items, or you can say item set. I is a item set. So the item set is represented here. So item set I1, I2 and up to IK, which are belongs to capital A. That means these two are interlinked with each other. And using this item set and number of transactions which are performed, we are going to calculate support of an item set. That means let us assume we are having two products. I'll just take one more product, that is three products. What is the possibility of purchasing I1 along with I2? This is one item set we can assume. And what is the possibility of purchasing I1 along with I3? And what is the possibility of purchasing I2 with I3? So here we are having three items. Along with the three items, we are going to find out what is the possibility of combination of items that they can purchase. What is the possibility of purchasing all the three items together? So like this, we are going to identify support of each and every item set. So here we are having three items are there. Here we are having three 2-item sets because there are only 2 items in the set. And we are having one 3-item set. We are having one 3-item set. Now, how this is going to be used in this analysis? Let me clear this one. Okay. Now, using this items and transactions, we are going to identify what is the support of an item set. Now, how can we calculate? The percentage of transactions which contain that item set is called as a support. What is a formula here? Support of an item set can be calculated as percentage of transactions which contain that item set. Let us assume here our item set is I1, I2. We want to see how many number of times this combination of products I1 and I2 is repeated. So to know this, we have to use this support of an item set. Now how can we calculate support for this item set? Percentage of transactions which contain that item set. Let us assume in 4 transactions the item set is repeated. That means 4 customers, they purchased this item set together. That means 1, 2, 3, 4 are the 4 customers, or you can say 4 transactions. In these 4 transactions, this item set is repeated out of 100 transactions. Out of 100 transactions. So here 4 transactions is having a combination of I1 comma I2. That percentage of transaction which contains that item set is called support of an item set. And next one, frequent item set, or you can say large item set. Among all possible products and items, what is the frequent item set which was repeated in most of the transactions? Item set whose number of occurrences is above the threshold. Here threshold value can be taken as user level. Let us say here we are taking threshold value as 3. That means how many number of item sets which are repeated more than 3 times. That we can consider. Less than 3 times we may not include for the analysis. So this is the main aspect here. Now look at here. Here the total number of transactions are represented as T1 to T5. Here we are having 5 transactions, and each and every transaction is represented with set of items have been purchased. Let's have a look at it here. Here we are having 3 items have been purchased in transaction 1. That means let us assume there are 5 customers. Customer 1 has purchased bread, jelly, peanut butter in transaction 1. And customer 2 purchased bread, peanut butter, only 2 items he purchased. And third customer has purchased bread, milk, peanut butter, 3 items based on the customer interest. When we are having these 5 transactions, item set I equal to, that means total number of items which are repeated. That means unique number of items are 5 items. They are beer, bread, jelly, milk and peanut butter. So there are total 5 items are there. Now what is the support of bread and peanut butter? That means how many number of times that bread and peanut butter is repeated. What is its percentage of among all the transactions? So bread and peanut butter is having a support of 60%. So here bread and peanut is repeated in transaction 1. Here it is repeated. Here it is repeated. In third one also it was repeated. That means together bread and peanut, 2 items together, in how many transactions they purchased. So here totally we are having 3 transactions have been purchased out of 5 transactions. Out of 5 transactions. So 3 divided by 5. So we will get 60%. Now, how can we define a rule? Till now we have seen a small example. In that we are comparing products, that is bread and peanut butter, how many number of times the transaction is repeated. So we got 3 times it is repeated out of 5 transactions. So we came to know 60% is the support of the transaction based on the selected item set. Now here, how can we convert that transaction into a formula or in a mathematical way? Let us assume X tends to B is an implication where X and Y belongs to item set. Here we are comparing an item X with an item Y, but both I and Y are belongs to item set I only. That means X and Y are the subset of I, and X intersection Y is equals to null, because there are no common products in item set X and item set Y. Support of association rule can be defined as X tends to Y, the percentage of transactions that contains X union Y. That means how many number of transactions X and Y. X union Y means X and Y together have been appeared in any transactions. So out of all existing transactions. We will take the percentage of transactions that contain X union Y. When it comes to confidence, support indicates that X tends to Y is already happened. It was completed. The transactions which contain X and Y is completed. From the completed list of transactions, we got some percentage of support. But when it comes to confidence, this is our prediction. That is, in how many number of transactions X tends to Y is going to be appear. Ratio of number of transactions that contains X tends to X union Y to the number of transactions that contains only X. So in support, we are taking like this, X union Y divided by total number of transactions. Whereas here, in confidence, we are taking X union Y divided by only count of X. Let's see this one. Here we are having that a simplified formula for both confidence and support. So support is the information which is already existed. Number of transactions in which A appears, number of transactions in which A appears, total number of transactions. Let us assume support of I1, I2. In number of transactions where I1, I2 is appeared and total number of transactions. When it comes to confidence, support of A union B divided by support of A. Support of A union B divided by support of A. That means number of transactions that A union B contains and number of transactions only A contains. Look at here. We took the same example, that is market basket analysis. Here we will compare. Let us assume here that the transaction is bread and peanut butter. Here we are comparing that. What is the support for bread and peanut butter, and what is the confidence for bread and peanut butter? So here we want to calculate support and confidence. So here we got 60%. Now what is the 60%? Totally we are having 5 transactions in that example. Out of 5 transactions, 3 transactions is repeated bread and peanut butter. That is 3 by 5, we got 60%. And 75% of confidence means bread is repeated nearly in 4 transactions. Only bread is repeated 4 transactions. Number of transactions is 3. So 3 by 4. Okay. So this is 75% transaction. Like that, if we compare how many number of transactions which bread and butter is repeated. If you look at here, in both cases support is same. Even though it is X and Y have been interchanged, we will get this. But when it comes to this confidence, peanut butter indicates number of times it was repeated in bread and butter. So it is got 100% confidence. So likewise, we can able to calculate all possible item sets, their support and confidence. Here for our convenience, we took only single item in both sides. That is, on left hand side, right hand side, we took only single item. But in real time example, on the left hand side, there is a possibility of having more than one item, like bread and peanut butter along with jelly, bread and peanut butter, milk along with jelly. So here on the left hand side, we can go for n number of items, or on the right hand side, we can also go for n number of items. Like this, we are able to predict all possible support and confidence. When we are having all possible support and confidence, whichever rules are feasible for us, we will select those. Let us assume we will put 50% as a threshold value for support. That means only transactions which are having 50% and higher support value we will consider for analysis. Remaining we will ignore for the analysis. For confidence, we can also put, or we can also change. Let us take 40% and higher transactions will be taken for confidence. That means these 3 are going to be taken for analysis. Remaining these two are ignored for analysis. So this is the way to predict and to calculate support and confidence for each and every item set. Among them, whenever you want to ignore any one of the item sets, we'll use this percentage of support and confidence based on threshold value. Now we'll see this association rule problem here. Let us assume we are having an item set I which contains m items, I1, I2 up to IM, and we are having a database transactions D, that already we have seen. D is the total number of transactions which are completed, where Ti and Ij are the association rule we are going to identify with a minimum support and a minimum confidence. Here we are trying to predict the minimum support and a minimum confidence between X and Y. Now, when we want to apply association rule technique, here find the large item sets, because when we are having more number of items, if we go with the smaller item sets, it may not give the proper feasible results. So here the first approach is we have to go for, and we have to find out large item sets. Using those large item sets, we have to generate rules from frequent item sets. Look at here. Here, if you look at item set word, it looks similar here. But here what we are doing, first we are finding all larger item sets. Among all these larger item sets, we are going to derive frequent. This is the key aspect. We want to find out most frequent or frequent item sets. How can we know which is frequent and which is infrequent? By using a required threshold. If you put the threshold value as 60%, above 60% transactions with support value can be considered as frequent. Now, look at this algorithm that we are applying in association analysis. So here the terminology which are going to be used as inputs, D is the database of transactions, capital I indicates number of items, and L indicates large item sets. That means larger items which are repeated in a transaction, or more number of items which are repeated in a transaction. And these two are the measuring values, support and confidence. In some cases, instead of alpha, we may use C. So this can also be used here. S for support, C for confidence, or S for support, alpha for confidence. And what is the output we are going to derive? We want to obtain rules or rule association rules for satisfying both support and confidence. Now, what is the formula here? Initially, we don't have any rules. So, in first step, rule equal to 5. That is null value. Now, what we are doing for each I belongs to L. What is L here? Large item sets. Each L belongs to L. Do for each X belongs to L. X is the value that you are taking for every iteration, such that X is not equal to 5 and X is not equal to L. Do what we are doing? Support of L by support of X, which greater than or equal to confidence. Then R equal to R belongs R union X tends to L minus X. Now, what is happening in this formula here? Initially, we are having 0 rules. Now, what we want to find out? We want to derive each and every rule for every iteration in the for loop. Now, what is happening in the for loop here? We are going to calculate support for each and every L here. Here L indicates one item, or you can say one item set. Let us take it is one item set. And after completion of all one item sets, we can repeat for 2 item sets. And this procedure can be repeated up to n item sets. So small L indicates starting value or a first value of item set. Like that, we want to repeat this procedure until we will get our required confidence. Say greater than or equal to confidence. Now, how can we fix this greater than or equal to? Here we are putting some threshold value for the confidence. Let's see this algorithm again. Here our input parameters are D, which indicates database of transactions, I, which indicates total number of items, large item sets. Here L, capital indicates large item sets, small l indicates all item sets, S indicates support, alpha indicates confidence. Now we want to generate all possible association rules or rules, that is capital R. Here we want to generate rules satisfying both confidence and support here. Now the basic algorithm is in the format here. So in first step we are assuming there are no rules here. So in rule database there are only 0 rules or null rules. Now when we are having 0 or null rules, what we are doing? We are repeating the process, that is L belongs to capital L. Now what is capital L here? It is capital L is a large item set, whereas small l is the all possible item sets. Let us say we are having item sets like this: A, B, C. These are the one item sets. We may have two item sets like AB, AC and AB. We may have three item sets like ABC. So if we assume there are three elements in a data set or item set, we got nearly 7 item sets. 3 one item sets, 3 two item sets and 1 three item set. We'll redraw all these again to understand betterly. Let us see here. We are having 3 items, capital A equal to A, B and C. These are the 3 items in that capital I. Using these item sets, what we want to do? We want to generate all possible item sets. So here A can be purchased alone. A customer may come to the shopping mall, he may buy only product called A, or they may buy only product called B or maybe C. That means they are purchasing only single item. And we'll see possibilities. Some customers may come and they purchase 2 items together. So there is a possibility they can buy A comma B. They may buy product A and C together, or they may buy product B and C together. AB, AC and BC. Some customers may buy all the 3 items together, A, B, C. Just have a count here. This is 1, 2, 3. So here we got 3 one item sets. And look at the 2 item sets here, AB, AC and BC. So we have got 3 2 item sets. And here we are having only 1 3 item set. So totally if we make it, it is count equal to 7. We are having 3 items. When we are having 3 items, we will get a item sets which is a possible of 2 to the power of n, where n equal to number of elements. Here number of elements are 3, it's 2 cube, you will get 8. But here we got only 7. That remaining one indicates null item. That is, nobody has purchased any item. So like this, we have to find out all possible item sets. 1 item set, 2 item, 3 item set, 4 item sets are up to, we have to go for n item sets. Based on the required larger item set that we can apply here. That is the meaning here. Here small l is among all these 7 items. L can be anything, and L obviously which is belongs to large item sets. And we are repeating the process for each x L such that x not equal to 5, that is x is not equal to 5 means any item they have to purchase. Out of 8, if we exclude 5, or null value, there is a possibility of purchasing these 7 item sets, and x is not equal to L. And we have to repeat this process, and if we found any rule, that rule we are adding to the existing rule here, that is R union. Now here we are going to apply a priori algorithm. In next session we will see the detailed information about how to use a priori algorithm with a detailed example. Thank you.